Hello, my name is Chris MacBain. I'm the Manufacturing Technology Manager here at GoEngineer, and I'd just like to welcome you to part 2 of the 3-part series on 3D printing. So today we're going to talk about the different technologies, and we're going to discuss the different technologies so you can kind of get a good idea of which one would be a good fit for your company. I'm going to cover the pros and cons of each of the more popular technologies out there. So in our last webcast, we just reviewed the 3D printing, kind of what it meant to have a 3D printer, how 3D printers work, the different technologies. We really concentrated on PolyJet and FDM, fused deposition modeling. Today we're going to go even more in depth on the pros and cons of not just these technologies, but all different technologies. So we have the fused deposition modeling, FDM, we're going to cover that. PolyJet Technology, the object machines, both by Stratasys. We're also going to cover selective laser sintering, or SLS, the powder-based part generation. We're going to cover ZCorp a little bit. Some of you out there might be familiar with ZCorp. We had a ZCorp machine in our office for a very long time. And then we're going to do MultiJet Modeling, relatively new technology out there. It's really good for really tiny little parts. We're going to cover that in a little bit. And last but not least, stereolithography. So, it really seems like every day there's a new technology springing up, whether it's plastic or chocolate or cement. There's always something in the news about 3D printing or rapid building, rapid prototyping, rapid manufacturing. But we're going to concentrate on this list of technologies today. These seem to be, as far as the engineering design world goes, these really seem to be the most prominent players. There's a lot of different machines besides these out there, smaller machines, but basically the technology is all about the same. So let's go ahead and get started. So let's talk about SLA technology, stereolithography. Stereolithography, the way that it works, it uses a laser to cure a resin. One little small layer at a time, and it builds up these layers to create your part. When it's cured, the resin's actually pretty hard. It's relatively easy to sand and paint and durable. I must have painted thousands and sanded thousands of SLA models in my career. It smells very chemically, I guess. It smells like cancer, basically. But it's a really good medium for making prototypes and models, especially if you need a nice finish on it. The standard color is kind of an amber, as you can see here on the right, that little housing there. But you can also get clear material. They also have a couple different flexible materials, things like that. It seems like every few years they come out with a kind of a new material, polypropylene-like or an ABS-like material, things like that. SLA has been around for a really long time. It was actually the first rapid prototyping technology that I was involved with. It must have been 15 years ago when I was at a model shop back in Chicago. So it's been around for a really long time. I'm sure you guys have, if you've been in the business and have seen any prototypes, chances are you've run across an SLA model. So they're really good for kind of a more or less durable model, especially if you have a bulky part. Speed, they're relatively speedy to get done, and they're generally, they're pretty good. The final product's pretty good. So if you're thinking about buying an SLA machine or investing in the technology for your company, it can be very challenging for a company to maintain a machine like this in-house. The machines are pretty big. They've got very specific power requirements. The machines need to be basically in a cave because the resin will cure if it comes in contact with UV light. One of the shops I worked at, we had to spend, like 2 days sealing up every window so not one little beam of light could come in and hit that vat of resin that's sitting in those machines. The machine, speaking of the resin, the machine holds gallons of this resin at any given time, and the resin is pretty caustic, and it's really messy. It's about the consistency of like a light syrup, and the leftover resin, stuff like that, it has to be disposed of according to like EPA regulations. You have to fully cure it. If not, it's all a hazmat. And the other thing too is, it's not only is it messy and it's big, but when the parts come off the machine, they're not fully cured. So there's a post-curing process which includes washing that part out with in an alcohol bath. So you need a big vat of isopropyl alcohol, and then once it's through the alcohol bath, it has to go into a UV oven and cure under UV light before it can be cleaned and finished and stuff like that. So the whole process, even though the model building itself can be relatively fast and you're going to get good parts, the whole post-processing of it can be pretty time-consuming. These parts aren't fully cured when they come off, things like that. These are just some things to consider if you're thinking about investing in the SLA technology. So let's go to MultiJet technology. So MultiJet modeling, this is relatively new. We're going to discuss a little bit about how it works. What it does is it actually lays down a microscopic layer of resin on a plate, and the layers are laid down as the plate drops down, creating your part. MGM's pretty good, or MJM's pretty good for really small parts. When the material's laid down, it's laid down on a support that's made of wax. On one way to look at this is that wax is very easily removed. It's just melted away. It's got very high resolution, so the surface finish and detail is very good. If you look at this picture on the lower left side of your screen, you can just see the fine details that you're able to get. These machines are very popular in the jewelry industry, very small patterns for jewelry, anything you really need super fine detail on. They're pretty good machines. Some of the drawbacks of the MJM technology, if you need very small patterns or very small parts with a lot of detail, MultiJet modeling may really fit the bill for you. But that ultra high definition goes away when your part size increases. So in order to build at that high resolution, the actual build area of the table decreases. It can't hold that tolerance across the whole table. So when you start doing bigger parts that you need very high tolerance on, it gets a little wonky and you're not going to be able to do it as good as a small part. The process is very time consuming just because it lays down such fine layers. You pay for that fine detail with time. And the build greatly increases, the build time increases with the size of the part. You can just imagine you're putting down this small layer, you're making a car like there on your screen on the lower right hand corner. It's not going to take that long. You're going to make an orange peeler or orange juicer there. It's going to take a very long time to do. There's another very unique attribute to MultiJet modeling, and that's that waxy residue. It's great because that wax melts away and it's easy to remove. The problem is the material itself has wax in it, and over time that wax seeps out of the part. So if you're painting this or sanding it or finishing it anyway, paint doesn't want to stick to these parts because there's wax on it. If you do clean it up enough and seal it well enough, the paint will bubble, the paint will peel off because that wax, it just wants to seep out of that part. There are ways to kind of force the wax back in, but you're never going to get totally free of that waxy residue. In order to do those really small parts too, there's some very specific settings that you need to adhere to produce those really small parts. Ultra high definition, as they call it. When you do that UHD setting, again, your bed size greatly decreases. There's some, I won't say tricks, but there's definitely some things you really have to pay attention to if you have one of these machines and you're making those really small parts. So let's talk about the ZCorp technology. Like I said, some of you guys might know this, might be familiar with ZCorp machines. This technology produces some pretty great display parts. The way it works is it cures a powder with an inkjet printer head. When one layer is cured, the new layer of powder is kind of rolled over the top of it, and then that layer is cured in the profile of your part, and over again, and it repeats, and table lowers until your part is produced. This is great for those presentation models because it prints in full color spectrum. which can really help with presentation models or trade shows or meetings or things like that. You can see that assembly on the lower left-hand side of your screen. All the different parts in different colors. It's pretty neat to go to a presentation and put this part on the table and have this full color part for you, right? For your customers right there. It's really easy for them to see. So, if you're thinking about getting a ZCorp machine, we at Go, we've had a ZCorp machine in house for years. I don't think we do anymore, but we had it for years and years. So we can really tell you firsthand that it's a mess. It is a messy, powdery process that is barely feasibly fun. So, when the part's done, what happens is, that part is encapsulated in powder, in this plaster-esque powder. It used to be cornstarch, and then they kind of switched to a plaster. So once your part's done, that powder has to be shaken, blown, sucked, knocked, or otherwise forcibly removed from the inside and outside of your part. So once all the non-cured powder is removed, you're really left with a pretty rough surface, as you can kind of see on that part in the lower left-hand corner. I mean, it's like a plastery, porous surface. The other thing about that that rough surface is because it's kind of a plaster base, it's very fragile. There's a lot of post-processing that needs to be done to this part, and it's kind of a pain in the neck to finish. The part has to be blown off, all the powder has to be removed from it, so you're blowing, sucking, whatever, it's a mess. And once you're done with that, you have to, in order to make the model solid enough to handle or bring to presentations, the whole model has to be basically covered in super glue and cyanoacrylate. I don't know if you've ever smelled super glue, especially in a large quantity, but let me tell you, it hits you in the back of your head for sure when you take a good whiff of that stuff. So you need really good ventilation. You're dealing with a lot of super glue, so I've glued my fingers together countless amounts of times. You can pretty much count on that. Little advice, if you ever do that, acetone, nail polish remover will take that super glue off of your skin, so you save you a trip to the hospital. But that's just the kind of stuff you have to deal with this model. But really at the end of the day, you're left with a part that has really cool colors that you like to look at, but it has pretty much no functionality past that. And to get to that point, it's a pretty messy process. All right. So hey, let's talk a little bit about SLS technology. So SLS, selective laser sintering. The way this works, it kind of works sort of like a ZCorp machine. It's powder based, just like a ZCorp machine, but the powder is a plastic. It could be metal, it could be ceramic, and instead of being cured with a printer head like the ZCorp machine, the SLS cures that layer, the profile of your part on that layer, with a CO2 laser. So it actually melts the surface of that powder to create your part. And because of that laser so strong, you can really do, they have a lot of different materials available for you. I've seen parts that were made of nylon, brass, titanium, aluminum. It all depends. Now, not every machine can do every part, every material. For instance, titanium, it's a very special machine that does it, but the process is basically the same. It actually melts or welds that layer of titanium powder to the top of your part. And because of the accuracy of that CO2 laser, you're really able to produce parts with some pretty fine details. You can see the ones on the right there, that fan blade or widget or whatever that thing is. It's pretty impressive. Way back when I was in the model shop, we had a part that was brass, that was SLS. It was a little bit different because it was actually impregnated with brass after it was modeled. But now with the technology, they can go ahead and just weld titanium together and metal and stuff like that. SLS is really good for fan blades, things with undercuts, things like that. Something that you might need metal for, or even a nylon. If you're doing, I did a lot of like battery housings, electronics housings, clamshells. You're able to do living hinges with SLS, so that helps out a little bit. It's kind of durable. This was, in my opinion, and at least what I've seen, is it was kind of the first rapid prototyping machine to become a rapid production machine because of the material qualities. This was the first machine I saw companies actually making end-use parts on. Again, it's all about material quality and resolution. So they have a really high resolution, which means you can get pretty good details on parts, and material strength, you're getting aluminum, brass, nylon, ceramic, all kinds of stuff. Now, just like the ZCorp machine, it's pretty messy. You have that powder, and instead of just a plaster-esque powder like you have with the ZCorp, now you're talking powdered titanium, powdered nylon, things like that. And with that great material quality and production capabilities, you may be tempted to kind of purchase an SLS machine, but here's some things to really consider. Those machines are not suitable for an office environment at all. They really have to be in a warehouse environment. They need special ventilation. You need to vent these machines out to get the powder out of there, things like that. Another thing about these machines is you really almost need to run these machines constantly to keep them in good shape. There's some technology we're going to talk about later where it doesn't matter. You can run a part, once a month, once every 2 months, once every 3 months, and be okay with it. Machines like this and the MultiJet machines, things like that, these machines rely on you running these machines almost constantly to keep the heads clean, the motors lubed, all this other stuff. If they sit for a long time, that might be an issue. The powder that these machines, that the SLS machines hold to, the process of loading and unloading the machine with powder, it's pretty time consuming, and I don't know that it's complicated, it's just really messy, where you would probably want, if you wanted to invest in the SLS technology, you would probably want a dedicated operator to run your machines for you. It would be one person's job to basically maintain and run these machines. I mean, they're a little needy on the personnel side. Another thing too is just like the ZCorp machines, they're kind of a pain to finish, the models themselves. You have to, just the peripherals. So you have the machine, so you spend hundreds of thousands of dollars on the machine. Well, if you look at the bottom right-hand corner, there's a finishing station where you knock the material off. It's a recycler. They have vents, things like that. Just the peripherals, not even the machine. Just the peripherals, the things you need to run the machine, will cost you about $33,000. So it's pretty pricey. It's definitely not for the weak-willed, without a doubt. Another thing about these machines too is it's really time-consuming. It's a slow printing speed. They have really big beds, but remember, they only have one laser that's actually tracing this part and going back and forth over this part. So you can imagine, the more details, the more surfaces that this part has, the more that laser has to track back and forth over this part. So it can be really, really consuming. The other thing too, the crazy thing about this machine is how long it takes to warm up and cool down. So to warm up, it can take up to 2 hours for this machine to warm up. So let's say you have that dedicated operator, you're paying them basically 2 hours to sweep the floors while the machine warms up before you can even run parts. And another thing too is the cooling down system. So in order to maintain this machine, to do anything inside of the chamber, the build chamber, change out things, you have to wait for it to cool down. The cooling down cycle is equal to the build time. So if you run this thing for 30 hours, you have to let it cool down for 30 hours. Now this is something that I was told that I didn't really believe, but it's a long time to wait for a machine to finish. And again, and they have kind of rough surfaces. What I've done in the past, except with living hinges obviously, is impregnated this with super glue also. It makes it a lot easier to sand, a lot easier to paint and finish. It gives you a nice solid thing. I've actually coated these with a urethane, with a casted urethane, 2-part urethane, to sand and finish these models too, and you get a pretty good result. But again, it's just it's really time consuming once you get the parts, the post-processing, all that other stuff. Alright, so let's talk about the PolyJet technology. This is what I talked about before. I covered this technology in the last webcast. The PolyJet technology basically works like your office paper printer. what it does is it goes back and forth, but instead of laying down a layer of ink, it actually lays down a layer of UV cured resin, photopolymer resin, and then it just lays these layers of this photopolymer down. As the table sinks down, it just builds your part up. Now, because it's UV cured, the parts may change characteristics over time. So, the more that these parts are exposed to light, they may warp or become a little bit more brittle. The support for this process, it's like a gel-like substance that has to be removed manually with a water jet. That's that good-looking guy right there spraying in the thing. I don't know why the lid's open. He's going to spray himself in the face, but it's basically just a power washer just with water. But every part has to be handled and rinsed off. It comes off remarkably easy, but you still have to take every part and put it in there and clean it off. And some people might think that the material also, these are some of the things to consider when you're buying these, might be a little expensive. Even though compared to SLS material or even some of the MultiJet material, it's less expensive than that. Some people might look at this, they sell it by the kilo or the kilogram. They might look at the material and think it's a little bit expensive. The build material is about the same for everything, so you don't have to worry about that. But the support material is a little bit less expensive. But these are just some things to consider before you purchase the PolyJet or the ObJet machine. So now let's talk about some of the good things about this. So some of the great things about PolyJet is, let's say you decide to get a PolyJet machine, right? So what do you get? You get a 3D printer that's really office friendly. This thing can sit in your office environment. It can sit near engineering or design departments for super easy access. So you don't have to walk down to the shop, request a prototype, wait for the machine to warm up or the lasers to get going or things like that, or fill with resin. You just go over the machine just like a regular printer and you can get parts out really easy. It's really easy to use and to maintain. Again, it's kind of made for an office environment. So it's very easy to maintain these machines, to clean them. You can see in that last, I don't know if you remember from the last slide, the material is actually self-contained in these cartridges that you just pull in and pull out. There's no pouring of resin or anything like that. So another thing too that's interesting is, unlike some of the other tech that I just talked about, the PolyJet machines, the ObJet machines, they really come in a bunch of different sizes. So you can really get one that fits your needs, something from a small desktop machine to one of the mid-size machines, which is the Eden. The desktop series, it really does rock for really small parts. You just need them on occasion. You're not running this thing 24/7, but you need a part once in a while. The desktop series is just really great for that. Then the Eden series, which is the middle series, goes into more materials and bigger parts. This is you're a little bit more demanding on your 3D printer. That's where the Eden series comes in. Now the Connex, which is the big boy, well, not the biggest there. If you look there at the picture, the very biggest one, that's not the Connex, the one next to it. It's for real serious users, right? It has all the materials. It does what's called their Tango material, which is like a rubber-like material. You can see the tire there. The one on the bottom is solid. The one on the top is like a rubber-esque material. And it's got a huge build area. Another great thing about the PolyJet technology is all in one print you can print overmolded parts. So you can print soft, flexible material right over or in or embedded or inside or outside of very hard material all in one build. Think of a remote control or any kind of handheld device where you have some kind of overmolding or softness to it. You can do that right there. Another good thing too is you get really small, really nice small features like small wall thicknesses, smooth surfacing, things like that. You get all of that with this PolyJet technology. So there are a lot of pluses to this. The quality of the model, ease of use, and what we call, the cost of ownership. Like, what does it cost you to own this machine? You don't need a dedicated user. It sits in your office. Very low maintenance on it. It is a really great machine. So let's go next to the FDM technology, the fused deposition modeling. This was Stratasys' flagship before the merger with them and ObJet. The FDM, fused deposition modeling. Last but not least, let's look at this. FDM, it's a process where a bead of thermoplastic is extruded and laid down on a build platform. Kind of, it's extruded, kind of like a hot glue gun. It goes down and it lays that bead of material down. These beads build up as the platform lowers, and this is what actually builds your part. You can kind of get an idea of that in that diagram in the left side of your screen. So a couple drawbacks of this FDM technology, one of those is the surface finish. If you need really smooth surface finish right off the machine, you're not going to get that with FDM technology. But because it's thermoplastic, an ABS, a polycarbonate, something like that, it's very sandable. But there is some post processing that will need to be done if you want to have a really smooth surface for your FDM parts. But another thing is limited colors. The ZCorp is on one end where they have every color of the rainbow. And FDM technology is you're kind of limited to what the color is of the material that's loaded in your machine. Now they have a lot of colors that are available, but you really have to, if you want to switch colors on a part. Let's say I've seen parts that were made with 2 different colors. You actually have to pause the machine, remove the material, put the new color in, and then restart, and then unpause the machine and feed in that new color. It's possible. I mean, it's not really hard, but it's not as simple as say the ZCorp or something like that. Another thing about the FDM technology is it does take a little bit longer than some of the spray technologies, the PolyJet or the MultiJet. The reason is just like with the laser technology, the sintering or the stereolithography, you have one extrusion tip that's laying this stuff down, so it takes a while for that tip to to go through and do the profile and fill in the gaps and all that other stuff with material as it goes through. So the build times can be a little bit long. So really, I mean, those are really the 3 biggest things: the surface finish. You get a little bit longer build times, and you have some limited colors. In the whole scheme of things, those aren't that bad, especially if you need a thermoplastic part, and that's where FDM really shines, right? So you've waited a little while for one of your parts to come off, and it's probably in one color. Okay, great. What can you do with it now? Well, this is where the FDM really excels. This is where it really shines. Extrudes real thermoplastic, ABS, polycarbonate, Ultem. It's not what others may call a quote, I'm making air quotes, you can't see it, a like material. You'll hear that a lot with other rapid prototyping machines or 3D printing machines, is like ABS like material, polycarbonate like material. That means that the resin, the material that they're actually spraying or extruding or whatever, it's not actually ABS, but the properties are close to it. With FDM technology, you get that actual plastic, ABS, polycarbonate, Ultem, things like that, which means it's very sturdy. The chemical properties are very easily found in reference manuals, things like that. Another thing too is the support process. The supports, when you build this machine, or when you build a part in this machine, are easily removed by just putting in this solvent, in this bath of a high pH water-based solvent. It's not even, I shouldn't say solvent, it's more like a solution. It's water-based, you can just pour it right down the drain. There's no EPA regulations for getting rid of it. That's the picture in the middle bottom of your screen. So you can actually see that, you just dunk it in there, you press the button, it circulates that water around, all of the supports are automatically removed. It's a hands-off process. It's pretty easy, right? So at that point, you were really left with a strong, durable, and very usable part. And because of that melt-away support, of that dissolving support, you can print working assemblies. You can print, that's that kind of clamp you see up there, that was printed all in one part. The space in between the moving parts is filled up with the build material, with the support material. That support material dissolves, you're left with a nice moving part. You can even make the whole model, if you want, out of that dissolving support material for what's called a soluble core for composite layups. So you can build the model out of support material and then wind or wrap or lay composite material over it, cure it, and then put it in that bath, and then that whole core just goes away, so you're left with a really nice composite material. Another thing too is because that material is real plastic and it's very easily bonded, glued, painted, polished, dropped, kicked, used in production, whatever you want to do with this stuff. It's very durable. I was just up at a customer in Salt Lake City, and they made these production testing equipment bumpers out of this stuff, and basically it was for the automobile industry. And this part came into this channel, and they used an FDM models as bumpers for this part as it kind of got funneled through this channel. And we sat there and figured out it got beat up like 100,000 times over the last 2 months or something. It was just crazy, and it was still usable. And the only reason they took it off the machine is because it looked weird. It was just dented up, but it was still working just fine. So that's the real advantage of your FDM technology. You're really left with some really good, durable parts. So we talked about the PolyJet, and we talked about the FDM and all the other things. Because of the huge benefits of the Stratasys line of both PolyJet and FDM machines, we here at Go, we're really proud to supply those to our customers. Those are the ones that we chose to present to you guys, to really have you guys have the opportunity to get these machines and get this stuff in-house. We believe that at no matter what stage of the production process you're interested in streamlining, we really do have a solution. Whether it's the Mojo or the U-Print for the quick design checks, the Dimension, or any of the PolyJet machines for prototyping or engineering studies, or the full line of Fortis FDM machines for real durable shop floor or customer ready parts, we have the right solution to fit your business. And not only do we have the whole line of Stratasys machines, but as you probably know, we're the world leader in SolidWorks, all the SolidWorks product line. We also have CamWorks for your CNC machining, Altium for electronic design, and then PLM for our Oracle, and Agile for our PLM. So whether it's a tangible part that you really want to hold in your hand for whatever, or a production part, or it's the software that gets you there, GoEngineer can definitely help you guys out. So, we really give you the power to innovate, right? We have a full product line. Everything that I talked about, all the machines that we sell, the software that we sell and support, we support all of that stuff. Training and implementation will help you with that, getting the machines up and running, the software installed, all that things. We also have a service bureau, so we have these machines in-house where we can bridge the gap between, when you purchase it to the delivery. Hey, I want parts now. We can definitely help you out. Kirk Brown is our in-house guy for Service Bureau. Great guy. He'll be able to help you out for sure. So, we've been doing this really for over 25 years. We have nationwide service. We're really committed to your experience because we really know that our success at GoEngineer really depends on you guys. All right, so hey, I just want to say thank you so much for taking the time and joining me today for this kind of overview on 3D printing. If you have any questions, please feel free to call this number on your screen or your local GoEngineer office, and they'll get you the right person to answer your questions. So I just want to say thank you.